Hello and welcome back to this next part of Chapter 2. Today we're going to start talking about histograms, which is part of creating distributions from the data. That is, seeing how the data is being distributed. So hopefully you've all been exposed to histograms, but they're a small graphical presentation of quantitative data. So you can actually see where they're at in the frequencies and then their bins. So typically you would place the variable of interest on the horizontal axis and the selective frequency and the vertical axis. So that frequency might be absolute frequency, relative frequency, or percent frequency. So absolute frequency would be the numbers we initially get. Relative frequency is when we divide by the total number that we have and we get a point something value, and then the percent frequency when we move that over to get the numbers then in percentage format. All right, so the frequency measure of each class is shown by doing a rectangle, and then so the base is the class limits or the bin size, like I was saying, and the height corresponds to the frequency. So we've got some examples coming up. So if we look at that, here's an example of this. This is in your book. So the class with the greatest frequency is shown with this one right here with the bin or size of 15 to 19 days and a frequency of about 8. So the next thing I'm going to do is show you how to create one, but we first need to get in the data analysis tool pack. So if you have Excel at home, it may not be installed. To see or make sure that it's installed, you go to File, go to Options, then you go to Add-ins, and if you scroll to the bottom of your page, I'll move this down so you can see. You'll see Excel add-ins. You'll hit go, and then you'll see the analysis tool pack. You want to check that, and you'll click OK. And that should be a one-time thing that you have to do. So then, in order to create the histogram, I'm following along on page 35. It says click on the Data tab. Then what you'll do is you'll look for the data analysis in the Analyze group. So we're going to look for an Analyze group. And for me, put it out at the end. So I'm going to do Data Analysis. Right? From there, we want to choose the histogram. I may not have hit OK, but I went back and hit Data Analysis again, and now it's asking for an input range, which should be, if I click here, should be this value. Then the bin range is this array or range. And then we want to do the chart output and click OK. And when we do that, you can see how it's listed here. It doesn't give us the same ranges that you see on the figure 2.12. I'm going to follow along in the directions here on page 35. So it says right click on one of the columns in the histogram. So I've got one of the columns. I'm going to do a right click, and then it says select Format Data Series. The Format Data Series, I'm going to click, and that selects all the columns. Then I'm going to do a right click, come down to Format Data Series, And you can't see this, but I'll shrink it over here. And then it opens up this format data series here onto the right side of your screen. When that opens, then you want to click the series options, which is these 3 set of bars right here, which it's already selected. Set the gap width to 0%. So we're going to do 0 here. Hit enter. And you can see it changes it quite a bit. And so you could go and you could play with the formatting of everything and go ahead and make other changes. But it's just a way to show you how to get that histogram and see how your data is being distributed in each of the bins. And so you know this 15 to 19 area bin is your largest with about 8, and so on. So I just wanted to show you how to get those bins, those ranges in there. And so you notice we're on this second sheet here at the bottom. And so we can actually type 10 to 14 here. Oops. Let's go ahead and just format this as general. So I've typed in those bins, but what I had to do is I had to actually make them a label. And the way you make something a label in a cell is you put an apostrophe first and then you type in what you want. Otherwise, it's going to try and do the calculation for you. So that's how we got those ranges in there for the labels now. And I went ahead and reset the axis so that the units our major would be 1, and then that actually put in the numbers in here, and I made the graphic bigger so that these numbers wouldn't be all squinched up next to each other. So it looks closer and closer to what the book is showing. Another thing that's important to look at when you've created a histogram is the shape or form of the distribution. So if it's not like a bell, then there is some skewness, and it's important that you understand what that skewness means, and so that's what we'll be talking about. So here we have 4 different types that you might encounter. So in this upper left-hand corner, you've got moderately skewed to the left. The skewness means where that tail is going. So it's not a normal distribution like you would see here. Ideally, this is what you would want. Same amount on each side of the highest point, then the next point, and so on. So if we were looking at grade distributions, we'd probably like to see, okay, what's the average number? So it might be C's, then we might have B's here, D's here, F's here, and then A's over here, a smaller number. And we wouldn't have as many bins, right? So back to this one, the moderately skewed to the left. So the tail extends further to the left than to the right. Okay, so example scores, you know, there might be no scores above 100%. So most of the scores above 70%, and only a few are really low scores. So let's look at the next one in the upper right-hand corner. These are moderately skewed to the right. So the tail extends more to the right. So an example of what you might be seeing here are housing prices. So there are a few high expensive houses, but then more lower priced houses. Now these scales would be different than what you see here. This particular graph then, or histogram, is called symmetric, or what you heard me refer to as a bell curve in terms of distribution. So the tails are equal, more or less equal on both sides. And so an example here might, if you have data from your SAT scores, the heights and weights of people, or something else that's normally distributed, they're equal on both sides. And the last one in our example is highly skewed to the right. It's not to say you couldn't see something highly skewed to the left. So you can see how it's huge here and then really small, and it gets smaller and smaller and smaller out here. So an example of why or where you might see a histogram like this would be housing prices, salaries, purchase amounts, and so on. Right? But it's really, there's very few high, and then there's a whole bunch out to the left, and they're lower. Then to add to our looking at our distribution of data, we might also want to calculate the cumulative frequency distribution. So that's a little different than the frequency distribution that provides another tabular summary for quantitative data. So again, we're looking at numbers. So it uses the number of cases, the class widths, the class limits that you got from your frequency distribution, but then it shows the number of data items with values less than or equal to the upper class limit of each class. So let's look at an example here. So you can see, okay, we've got the cumulative frequency, how many were in each of those classes. Then we got the cumulative relative frequency, and then we have the cumulative percent frequency. So to me, the book, goes through different ways that you can calculate this, and it seems like it makes it kind of difficult. But if you get the percentage frequency for each of these numbers, all you're doing is adding on to the next one. So we've got a bunch of numbers here. Those numbers represent, I believe, we said 50, right? So I've brought the actual bins over in the frequencies. So we got 4. Where did this 12 come from? So you can think of these as, okay, I'm starting at, here's the lowest bin that had 4 in it. Well, the next lowest bin had 19, but less than, or combining both of these, at 4 plus 8, that's where the 12 came from. Then we add the 5 onto that gets the 17, the 2 onto that is 19, and then the 1 onto that is 20. And so then if you have percentages over here, all you're doing is adding up the percentages as you go. So less than a 19, that means that's combines both of those, that's 60%. Less than 24 is 85%, less than 29 is 95%, which means that this bin contains only 5%, which was the 1 divided by 50, I believe. All right, so to me, what I would usually do is go ahead and get these percentages out to the side for each of the bins. And then when you wanted your cumulative percent frequency, you just add that frequency here and then add the frequency here to this one, and that gets you the next number. Okay? Let me see if I can bring that over for you so you can see it. So here's what I did. I must have used the 50 from a previous example. It's only 20. There are only 20 observations here. So 4 out of 20 represents 20%. 12 out of 20 represents 40%. 17 out of 20 is 25%. 19 out of 20 is 10%. 20 out of 20 represents, or 1 out of 20 represents 5%. So, like I was saying, you get the individual percentages out of the total that you've gotten. So this, again, we have this. And so the cumulative percent is, okay, well, the first 4, that's still 20%. But now if I go to the second bin and add that, 40 plus 20, that gives me the 60%. 60 plus 25 gets me the 85%, and the 10 plus 85 gives me the 95, and so on. So the way your book explains it, I'll let you read that and see if you have any questions. Basically, it's like, okay, add up all of these numbers. So 17 divided by 20, that should be 85%. Next thing we want to talk about is measures of location. Where does the data fit in terms of the other data that's in your sample? So this should be a review of what you learned in Econ 206, but it's how do we calculate the mean, median, and mode, and the geometric mean. So sometimes you see this as the average. And the average then is just sum up all of the values you have. So each one, measurement 1 is x1, measurement 2 is x2, all the way out to how many you've got. And you divide by your total number, n, and that gives you the mean. And that mean is represented by x bar, so it has a line over the top of it. But it's just summing them all, divide by n, and you're good to go. Okay? Now, some things to know. X bar is the sample mean or sample data. If you see something like a mu, looks like a U, that's for the population data. It's slightly different. And so we'll see that here shortly. So here we have some examples. We have 12 home sales. Here's the price of each home. How do you get the mean? So there are 12 of them. We sum all the numbers up, divide by 12, and so the average or mean home sales is 219,937. I would pull that data file from your student data file and see if you can get the same number. So you would use the average function. The next thing we want to talk about is calculating the median. And this is the middle value in your data. So you want to arrange your data in ascending order. So the middle value for the odd number of observations, so there's going to be an equal number of observations on each side. If you have an equal number of things that you're taking measurements or observations on, then you take the two middle values and you average that, and that becomes your median. So here's an example. We have class size of 5. We have the different data points. We have arranged them going from smallest to largest, and then we choose out the middle number. Since this is 5, 3 is the middle one. And so this 46 represents the median. What happens if you have an even number? Then again, you would arrange the data in ascending order. So we have 12 there. So 12 divided by 2 is 6. So what do? We pick out this number and this number. Now we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 on each side of those two numbers, and we average those, and so then that becomes the median. Okay. Another term to understand is mode, and we'll explain more why you would want to know these measures later on and throughout the semester. Right? So mode is the value that occurs the most in your data set. How many times does it repeat? So look at this data set here. We see that we have two 46s, so the mode is 46. Another term is multimodal, and here the data then contains at least two modes. And bimodal means the data contains exactly two modes. So there's two, think about this as two things that are repeating twice. So let's say we had another 32 up here. Well, then 32 was twice and 46 was twice. Then we would have two modes. So let's look at the home sales data. You can grab that out of your data files, and we can actually create or look at and calculate the mean, the median, mode 1 and mode 2, and so on. So the mean can be found in Excel, like I said, using the average function. So you would say the average of B2 to B13. Right? It's showing you what those formulas are. The median can be used using the median function. So you got B2 to B13 again. So in Excel, for mode, you got mode.sngl, which is a single most often occurring value. So you can use that if you just think you have one. If you have multimodal, then you would use a function called mode.mult. So this is a array function again, which means it has to be entered with a Control-Shift-Enter. To find a multimodal value, like I said, you use the mode.mult. You would select, in this example, you would select E4 and E5. That's both of them together. Then, so that's the array that you're creating. Then you would enter the formula, mode.multi, or mult I should say. You would select the first value in your range and the last value in your range, and then hit Control-Shift-Enter. And that would generate the results that you see here. Now it just so happens that 138,000 is one of those modes that's repeated. It just happens to be in the first set. One measure of location that you may not have been exposed to is something called a geometric mean. So it's a calculation that's used for finding the nth root of the product of n values. And so where is this useful? It's useful for growth rates in financial data. So if you're looking at growth rates, this geometric mean may be something that you want to use. So notice there's a little g out by the x bar. So you take up all your numbers, how many you've got, n. So if there's 7, then you would have 7 values and you'd multiply them all together. You take the 7th root of that, not the square root. Or writing that a different way is multiply them out and then do 1 over whatever n is that you're looking for to that power. Okay? Easy thing to do in a spreadsheet. So the example that they use in your book are the percentage annual returns and growth factors for the mutual fund data. So look at the percentage annual returns and growth factors for the mutual data for the past 10 years. And so then you might want to know the mean rate of growth for the fund over the 10-year period. Think about that. The mean rate of growth for the fund over the 10-year period. So that's going to give you a little different calculation than just the mean. And so sometimes if people are just using the mean, they may not be giving you, well, they're not giving you accurate information. And then you're making bad decisions on that. So here we have our data. And so we're going to compute the geometric mean. Again, we're going to take all of those, multiply them by each other, the growth factors, and we see if on $100 what that would be. The geometric mean then of those growth factors, we take that, this value here, 1.335, multiply it by the power of 1 over 10, which is 1.029. So then we can say the annual returns grew at an average annual rate of, you can get rid of that $100 with the 1, 2.9%. So we got 0.029 here. Move that over to, that's where the 2.9% came from. Practice doing this, think about it, see if you agree or not, and ask questions. The nice thing about this is that if you're using a spreadsheet, you could just say, I want the geometric mean of this range right here, and it calculates it for you. So you use geomean and then specify this range as its arguments. Fairly easy to do. And so that ends the material that I'm going to cover for this week. Next week, we'll start off with measures of variability.